Hey guys, it's Booth Dog again. Hope you're all doing well. I know this is definitely going to be an adjustment for everybody, so just know that I am here if you need absolutely anything. Before Mr. Boothman's going to deliver some lessons very shortly. Why don't we bring him on camera now? All right, Mr. Boothman here. Let's get started. All right, good morning, everyone. Day 2 of this interesting experience, as well as 10.4. So we are going to continue 10.4 today. That is talking about the remainder theorem and finding the Lagrange error bounds for a given Taylor approximation for a function. Before we get started, some brief announcements first. You will have another exit ticket today as a Google form. Unlike yesterday, instead of submitting a question about the lesson to me, I would like you to submit pictures of the first 2 pages of the mastery sheet. Right now, I'm going to go through a couple of these problems, but I would like you to finish those 2 pages and then just take pictures of your work, even if it's on a separate paper or whatever. Upload those. Let me know if you have any issues uploading those, but I will put in this grade just for completion to see if you're working through it, okay? All right, I would like to go through 1 or 2 problems, at least from the first page, okay? Looking at the first question, what is the Lagrange error bound for the approximation sine of x is approximately x when the absolute value of x is less than 10 to the negative 3. This means that we're bounding x, we're looking at the interval, and it is not inclusive, so we're looking at the interval negative 10 to the negative 3 to positive 10 to the negative 3. Okay. Well, our f of x equals sine of x. And this right here, x, is the first order Taylor polynomial for sine of x, which means that our bound must be less than or equal to the absolute value of the maximum second derivative of our function times x minus a squared all over 2 factorial. Remember, this right here is simply the maximum value of the next term in our Taylor series if we were to continue. Okay, so this is just from the Taylor series. That means we need to find the maximum second derivative value. If our function is sine of x, then our first derivative is cosine of x, and our second derivative is negative sine of x. Now, on this interval, negative 10 to the negative third to positive 10 to the negative third, the function negative sine of x is constantly decreasing, which means that we hit a maximum value at the beginning of the interval, at negative 10 to the negative third. Okay. And I suppose we should be inclusive, so we can actually plug in this value. Taking this and plugging in remember, we're centered at 0, so a is 0. Okay, using a calculator, I used Wolfram Alpha, we get an approximate value of 4.999 times 10 to the negative 10 power, which is an incredibly good approximation. Most of you know I did start as a physics major. We used this approximation quite frequently. Sine of x is approximately x for very small values of x. And as we can see, it's extraordinarily good. Number 2 is very similar, if not exactly the same as a problem we did in our notes yesterday. I would like to look at number 3. And then we'll basically be done for the day. All right, so we're told that the square root of 1 plus x is approximated by 1 plus x over 2 when x is very small. Find the maximum error for this function using the given approximation on negative 0.1 to positive 0.1. Well, f of x equals the square root of 1 plus x. This is another first-order Taylor polynomial, which means that our error must be less than or equal to the next term in our Taylor series, which is going to be the maximum value of the second derivative of our function times x minus a squared all over 2 factorial. Our first derivative, if we think of this as x plus 1 to the 1/2 power, then our first derivative is 1/2 1 plus x to the negative 1/2 power, just using power rule. Our second derivative is negative 1/4 1 plus x to the negative 3/2 power. And this function itself, if we check, we pull up a graph, which is what I did. And this function is increasing on our interval, which means that it has a maximum at the end of the interval, so at x equals positive 0.1. So we plug in these values. Second derivative at 0.1. Again, this is centered at 0, so a is 0. And we get approximately 0.001. So another very good approximation, at least for numbers very close to our center at 0. And if my memory serves me correctly, we actually did this very problem way back when we talked about linear approximations in Unit 4. So maybe Unit 5. I believe it was Unit 4. The linear approximation is simply the first order Taylor polynomial. Okay. Now, going back to the rest of our mastery sheet, that's basically the first page done for you. The second page, it's labeled harder problems to practice with, okay? So like the first problem, do your very best. It's okay, again, I'm checking this for completion. Did you attempt it? Do you have some work there? Number 2 and number 2, those are really going back to the first half of this unit, constructing a Taylor series, constructing a Taylor polynomial, using it to approximate things, and then we're tacking on this new idea of the Lagrange error bound. Okay. Remember that this symbol right here, the upside down A, means for all, so for all x. Okay, so do your best. Talk to me during Q&A time. Otherwise, please submit pictures of those first 2 pages completed by the end of today. And remember that you have an AP Classroom assignment due tomorrow. I will be putting that in as a grade for completion after tomorrow. If you don't submit it by tomorrow, that's fine. I'll still accept it later, but it will go in as a 0 until it is done. Okay. So let me know if you have any questions. Have a great day. All right, well, that's it for today. Hopefully you're starting to get into some sort of a routine. Again, let me know if you have any questions or concerns. Email me, Google Meet during our Q&A time. Anything you need, I'm here for you. All right, have a good one. And make sure to hit that like and subscribe button on your way out.